Hello guys, welcome back to my YouTube channel, Revit Wiz here. Today I'm going to show you how to do a structural steel staircase with your own thread, being the vastrap thread that we use in South Africa, and also having continuous stringers throughout your staircase. So please stay tuned. So let's get straight into it. We're going to go to Architecture tab, then Stairs. Then we're going to select the industrial and assembly stair, which is the standard one. Then we're going to pick the ground floor to the first floor, and both must be 0. So that's fine. And then the thread we can make 250. And then the riser, that will sort itself out as we go up with the levels. Then the run width, we keep 1.5 here. And then we want this to be at the center. That just means when we start clicking, your cursor is in the center of your staircase. If I change this to the left, you'll see it goes to the left of the staircase, your cursor. So we want to do the center like that. So we want to start from this edge, going up to 8, 9 rises. Then we start somewhere there to form the landing and go up like that. So we just randomly draw it in for now, and then we can start making it look the way we want to. Okay, so let's go to the 3D and view that. So here it is, but obviously we don't want it in this position because there's a wall there. So let's just move it over. You just click on the staircase, press MV on your keyboard, and then just move it up like that. Okay guys, so if we click on this, we can see that we have desired number of rises 17, and our actual riser height is 176.5. So let's just go and draw a section for ourselves to see how this looks. Just make that a meter. Alright, go to view. Let's just make this fine, and then wireframe so you can see that all the threads. I'm gonna move this out. Okay, let's just dimension this to give us a better idea what we're working with here. So here you can see we have a really odd shaped staircase that we want to change and make it our own. But we can see we want rise it too far away from the building. So what we can do is let's go to the ground floor, you can click and say edit, and we click on this and just pull this one to the left. It will make the rise on this side jump to the right. So then we will have a staircase that looks like that. Okay, so now we're going to change our settings on our staircase. So we're going to say edit type, duplicate. Let's just call this steel staircase. So we want to start with the stringers first and give it a steel support. So if you click on here, you can say stringer closed. That's what we want. But the support is currently a default section. So if we click on this 203 I-beam, we're going to see what happens now. So let's go and say okay and apply. I just want to show you guys this an example. So let's go to the 3D to see this a bit better. So now you can see there's a I section that's been generated all around this staircase. Okay, so that is what we essentially want. But we want a PFC channel which works better for a staircase. So let's just click on it again in the staircase and say edit type, and then we can go to this area here. So obviously you'll see I changed this 203, and why it changed everywhere or on the left and right hand side of the string is because here you'll see the stringer 50mm width is selected on both. So I actually should have duplicated this and give it another name, but I'm going to show you what happens if we change the left support and we change that to the 50mm one, which is still on the default, and say okay, apply, and okay. So what you're going to see now is now you have an I-beam going all around on the right hand side of your staircase, and on the left hand side you just have this 50mm width of steel member that's going up, but we want this to obviously look the same. So this was just to show you how the staircase works. So now we want to load in a profile. The reason why we want to load in a profile is to be able to change this to what we want. So you can see here it's a section profile. So what we do is we go to insert, load family, and then what we want to do is you in your library you go English or whatever language you are. Then I'm gonna go to the US. Then you look for profile, not for framing, because framing is something different when it comes to a staircase. You're gonna use the profile which forms your frame, basically. So I'm gonna choose profile, and then inside of profiles, you're gonna have the framing selection. Then you're gonna select steel because we want to do the steel staircase. And then I'm gonna use a parallel flange channel. I'm gonna open it. Now I'm going to select, just for this example, a, let's say 200 by 75, and it's going to load it in. Okay, so now what you're going to see is once we open this again and we go to the stringer and we click the drop down, you will see that our parallel flange channel has been loaded. Now I want to duplicate this and call this 200 by 75 PFC stringer. Okay, now I'm gonna just change it to 200 by 75. There we go. Then I'm gonna click here by category, and I'm just gonna make this S3 by 5. That's the steel that I want, the metal steel, and say apply. Now you'll also see here structural depth on run and structural depth on landing. We'll get into more detail with this in a moment. So let's just say okay, and then we're going to change this on the left hand side. The type we're going to change to the same stringer, and then we will just come back to this again. Okay, so that is the stringers. So let's say apply and okay. So now you see that our stringer is actually faced inwards. So the open side is to the inside of the staircase. That's not what we want. So let's go edit, go to our stringers again, and you're going to say flip section profile and apply. So you don't have to say it on the left hand side one because it's the same thing, because the type of stringer that you've chosen is exactly the same for the left and right hand. So what you change on the right hand under this stringer profile, it will automatically change if selected under the left support. So let's go back. So now you can see there our channel is running. Now if we just go back here, you'll see that our riser and thread is sticking above, but we want it to sit, just going to draw a line here. We want it to sit something like that on the inside here. I'm just drawing, not drawing 100% correct, but it gives you an idea where we want this to sit. Okay, so we're going to go edit. We're going to go back to the stringer, and now we're just going to play around here. Let's make that 0. That is for the structural depth on the run. The run is the diagonal portion, which is where you basically walk up on the staircase, and then the landing is where you actually walk on the level which you can rest at, basically. So let's just make both of them 0 to see what happens. And okay, so now you can see it sits within our channel. That is what we want. So let's just go to the ground floor and just pull this to the edge to see what we're working with here. There you can actually see the channel in the background. So if I go to the 3D, this looks a lot better now. I'm just going to remove the rails because in structures we don't need the rails to indicate it in this instance. So you're going to say VV and then we're going to go railings, click it and say apply. So we can just understand the staircase a bit better. So now you can see we have this staircase here, but we want to make some adjustments to the treads because this is an external staircase, maybe a fire escape, and what we call in South Africa a vastrap plate. We want to do a staircase like that. Okay, so now we're going to go in here and say edit, but now we're looking at the run type. So at the moment we have a 50 millimeter thread with a 13 millimeter riser, but we want to make our own one now. Say duplicate and just call this vastrap plate. Say okay, and now we're going to change everything on this settings. But before we do that, we first want to load in a thread profile which we are going to create ourselves, because currently there are two profiles that we've loaded, but we obviously don't want to use a channel or eye section. So for now, just say apply and okay, and apply and okay. Now we're gonna create our own profile. Okay, so what we want to do is go to file because we want to create family. Go to new family and we go to metric profile. There we are, and say open. So I already have a thread that I did in AutoCAD. So I'm just going to import my AutoCAD. You can draw in one, or you can also get a standard that you use at your company or standard that you prefer. So I'm just going to align this to the reference planes. Now I want to create a line profile. So I'm going to say pick lines and I'm going to click on, or I'll hover over this and press tab. So it selects all of those lines. I'm going to do the same with the angle. You can't have the lines running over each other. You need to have one continuous loop. So if I take this through and I try and load it, it's not going to load as a profile because you need the loop to do a full loop. Okay, so now we're going to add in some dimensions and give it parameters so that we can change this whenever we want to within our project. Okay, so let's quickly change this and call this thread width, and this we can call vastrap height down, and that one vastrap height up. And then this one, you can just see if this is going to work. Let's call this angle distance. Okay, let's just see if this works. If I change that to 105, yeah, that moves the angle. But let's do a formula. So let's go family types. Just change that to 250. Say apply. And now we're gonna do a formula here that says we want the thread width divide by 2 minus 25 mils, because my angle is a 50 by 50 angle. So let's see, apply. So that is then going to be in the center of the thread. See, there we are. So let's say we change the thread to 300. There it's still central. You can double check. It's 50 and that should be 125. There we are. Let's just change that back to 250. Now let's just go to family, category, and parameters. We want to change the profile usage to a stair thread to ensure that it loads in the correct position. Okay, so now that we've set all this up, we can load it into our project, and there it should have loaded in. Let's go and have a look in the 3D, then edit the run type, which we've already created the vastrap plate name earlier. Let's go here. There it is, family 3 is what this is called. So you can double check that by going into this reference level. There it is, family 3. So you can save this and call it vastrap plate or whatever you want to call it, but just make sure you know what it's called once you've loaded it. So to edit the thread, we're gonna click on it, the staircase, edit. We're gonna go to the vastrap plate, which we created earlier. Then the thread thickness is the 4.5 mils. That's the thickness of our profile that we've created, the family 3. Then the nosing length can be 0. Nosing profile can be default. And the riser we can just untick because we actually created our own thread, which is part of the riser with those up and down plates that we have. So we're going to say apply, okay, apply, and okay. And there you can see our plate being displayed. Now, if we go to the section, you can see that we want these plates to sit more central to the stringer. The same with, oh, actually the landing, we want that plate to sit on top of the stringer. Okay, so what we're going to do is click on the stairs, edit, type, go to the vastrap plate again. Actually, apologies, we go to the right support, type, the stringer, then the structural depth on run, that is the plates relative to the diagonal stringer. Let's make this 40 mils, and then structural depth on the landing we make 200 mils because that's what the stringer depth is, and say apply. Let's see how that displays. Okay and okay. See, so that looks fine. It's within our stringer that they can weld these vastrap plates and the angle to our support, and then also our vastrap plate sits on the landing on top of our channels, and that is what we want to see. Have a look at the editing of this profile that we set up for this thread. So I'm just going to dimension the parameters that we actually set for this profile earlier in this tutorial. So I'm going to show you guys how this affects the changes. So what you can do is, we know that this thread is called family 3. So we're going to search it in our project browser, so it pops up there. Then you're going to double click on it. Then it's going to open your properties. So now we can change these parameters. So let's say we want to change the thread to 270 and say apply. It actually does that. So now you have a 20 mil overlap of your threads, which is okay. Now we can do the one that says up. We can maybe make 80 mils. there it goes 80 mils. And then let's say we want the bottom one, or the one that goes down, also to be 80. And it looks something like that. So you can almost join them. So that's how you can edit your profile within your staircase. What we can do is maybe let this also look like a vastrap plate. So we can download vastrap image. So I've already downloaded an image for the vastrap. So let's click on the stairs, say edit, go into vastrap plate. Then we're gonna go to thread material. Then I'm gonna select the metal. Make sure it has this generic image area. So we're gonna say duplicate assets and material. Call this vastrap plate. Okay. Then we're gonna click on this image. Then what I want to do is load in my image. Literally click on that image there. Then I'm going to go to, which is this one here. So open. There you can see that's what we have. That's what we want to see. Leave everything as is and say done. You can go and play around here and change whatever you want, but this is actually okay as is. Just say apply, okay, and then apply and okay, and okay again. Now if you zoom in, you will see that it actually has this vastrap image, and that is what we want to see here. Okay, so let's try and make this a bit better, these intersections here. So we're gonna click on the staircase, say convert to sketch based, and it's gonna just give you this warning to say you can't change it back. So close, that's fine. Now we're gonna go to the ground floor level, and we are going to sketch this area. So we're going to say edit sketch. Now I want to make it flush with the back side of the existing channel on the run. So that's what I just did there. So I'm going to say done. Just say unjoin. So it's going to look very odd now, but this is the shape that we want because we want the stringer to be continuous. Then we can do the other side. So I'm going to say landing. Then I click create sketch. Then I do the same rectangle here, like that, and I'm just going to align them to the edges where I want, to the inside of the channel, resolve. So here I want to delete that because I want that stringer to be basically continuous. So let's just go to the 3D. Just make sure that this level is the one for 11.8, and then we want that on the same level, like that. So there we have our stringers. So we want it continuous, but now we need a vastrap in this area as well. So back to ground floor, going to say create, apologies, just back, say landing, there create sketch. I'm going to do another vastrap landing, just make sure your relative height is correct. Say done. Now it's going to look very odd. I want to show you now, but we can delete the stringers that we don't need. So we don't need the ones facing outwards. We don't need that one. And that one at the back is fine. So it might look a bit odd, but the sense is that we want the stringer on the side to be continuous all around, even though it intersects there. And then the one at the bottom is also continuous, which is 100%. And then we say finish. Okay, so let's just go to the section to see how it looks. So this is what we want. We want it to be continuous, 100% like that. Then we want this stringer not to be vertical cut, but more horizontal so it can fix to a base element. So you hover over the staircase, press tab to select your stringer, and the lower end cut we're going to make horizontal. See, then it snaps like that. Let's go to the 3D. There you can see it snapped like that. So then you can fix it to this hard stand, or you can do a base in this area. But we can do the same with the other side. Horizontal cut. See, there it snaps perfectly. That is what we want. Okay, now we can just put in some columns on the edges maybe. So let's do that. We go to the ground floor. We're going to say structure, column. Now we have all these big columns. Let's maybe use this circular hollow section one. It's going to be quite big, but that's okay. We say we want it at a certain depth because we are on the ground floor, rather, let's say height. We're on the ground floor to the first floor, but we will fix that now. Let's just click something like that. So it's in that corner. Let's see how it displays in the 3D. That's not what we want. We want that to actually sit at the landing level. So let's go to the section. Let's create a level for the landing. Create similar. Going to select the level. That is going to be that level there. Okay, so let's just pull that. Just make this one to 25, the scale. So what I can do now is click on the column and say I want it to go to level 7. Just rename that, call it steel landing. Okay, then we know that that depth there is 205. So just minus 205 from your top offset, then it will sit below your supporting channel like that. We can just mirror our support DM to the other side. That's it there. Just make sure the copy is on. Then we have it like that. But these circular hollow sections are quite big. But for this exercise, they should be fine. And let's just have a look at these top ones. They actually need to be vertical cut. I see the other side is correct. Vertical cut. That's fine. Okay. So guys, that is how you do a steel staircase, your own tread staircase. So please like and subscribe if you would like to see more of this type of content. Thanks guys.